Hello everyone and welcome. I'm excited to have you here today. In this presentation, we'll be exploring Understanding React Native, a comprehensive guide. We'll cover the essentials of what React Native is, how it works, and why it's such a popular choice for mobile app development. We'll also look at key features, best practices, and some real-world examples. Let's get started and dive into this fascinating topic together. So, what exactly is React Native? Well, React Native is an open-source framework created by Meta, designed specifically for building native mobile applications. It uses React and JavaScript, which many developers are already familiar with, making the development process more accessible. The really powerful part is that with React Native, you can write a single code base that works seamlessly on both iOS and Android devices. This means less duplication of effort and more efficiency. Now, unlike traditional web-based React Native doesn't just render web views. Instead, it leverages native UI components like view, text, and image. This is a crucial point because it allows your app to look and feel like a truly native application, providing users with a better experience. So, in the context of our overall discussion about cross-platform development, React Native stands out as a tool that combines the best of both worlds: the flexibility of React and the performance of native apps. Let's take a closer look at the key differences between React Native and React, also known as. Starting with React, it's primarily a JavaScript library used for building web user interfaces. It works by rendering content directly to the Document Object Model, or DOM, which makes it perfect for creating web applications. When you work with React on the web, you'll typically use web-specific components like divs and paragraphs, and you'll have limited access to device APIs such as the camera or GPS. Now, React Native, on the other hand, uses the same core principles: components, JSX, state, and props, but it's designed specifically for mobile app development. Instead of rendering to HTML, React Native renders to native mobile widgets, which means the components you build look and feel like real native app elements. You'll use mobile-specific components like view and text, and you'll have direct access to device APIs like the camera and geolocation. In essence, React is tailored for web development, while React Native is optimized for creating mobile apps. Both leverage React's declarative approach to UI design, but they target different platforms. Understanding these distinctions is crucial as we move forward in learning how to build cross-platform applications efficiently. Components in React Native are really the fundamental building blocks of your app. Think of them as the reusable parts that come together to create the user interface. Each component represents a specific part of what the user sees and interacts with. You can define these components either as JavaScript functions or as ES6 classes, which gives you flexibility in how you structure your code. For example, I might write a simple function called greeting that takes in props. Those are the inputs or data you pass into a component. Inside that function, I return some JSX that uses other components like view and text to display a message. In this case, greeting shows a personalized hello message with the name you pass in. What's important here is that components can receive inputs, called props, which makes them dynamic and reusable. They can also manage their own internal state, so they can change over time based on user interactions or other events. This modular approach allows us to break down complex user interfaces into manageable, reusable pieces, which is a central theme in building efficient and scalable React Native apps. Let's talk about props and state in React Native, which are fundamental concepts for building dynamic components. First, props or properties are inputs that we pass from a parent component to a child component. Think of them as the data or configurations that a parent provides to customize the child. For example, if we have a greeting component, we might pass a name like Alice using a prop. Greeting name equals Alice. Inside the greeting component, we can access this prop with props name. The important thing to remember is that props are read only within the child component. They shouldn't be modified there, only read. Now moving on to state. Unlike props, state is data that a component owns and manages itself. It's used for data that changes over time, like user interactions or dynamic content. When we initialize state inside a component, We can update it using functions like setState in class components or the useState hook in function components. For example, we might have a count state initialized at 0, const count, set count equals useState, 0. When we call setCount with a new value, React automatically re-renders the component to reflect the updated state. The key difference here is that props are fixed by the parent, while state is managed internally and is dynamic. This distinction is crucial because it helps us control how data flows in our app, props for external input, state for internal data that can change over time. This dynamic nature of state is what makes our components interactive and responsive to user actions. Now, let's talk about the core React Native components, which are the fundamental building blocks for creating mobile user interfaces. React Native offers components that are very similar to HTML tags, making it intuitive for developers. First up is the View component. Think of it as a versatile container, much like a div in web development. It's used for layout and styling, helping us organize other components and structure our UI effectively. Next, we have the Text component, which is essential for displaying any text content. Remember, all text must be nested inside this component to ensure proper rendering and styling. Then there's the Image component, which allows us to display images within our app, whether it's icons, photos, or illustrations. The Scroll View component is particularly useful when content might be larger than the screen, as it enables scrolling, ensuring users can access all information smoothly. For rendering long lists of data efficiently, React Native provides flat list and section list components. These are optimized for performance, especially when dealing with large datasets, by rendering only what's visible on the screen. The Text Input component is crucial for user interaction, enabling text entry fields where users can input data, like names or search queries. Finally, we have touchable components like Button, Touchable Opacity, and Pressable. These handle user taps and gestures, making our app interactive and responsive to user actions. By combining text, image, and view components, developers can build a wide variety of static user interfaces, laying the foundation for more complex and dynamic apps. These core components are vital because they give us the flexibility and control needed to craft engaging mobile experiences. Let's talk about styling components and layout in React Native. First, React Native uses Flexbox for managing layouts, just like in CSS, but with some differences. It's a powerful tool that helps us create flexible and responsive designs. Alongside that, we have a JavaScript-based stylesheet system, which makes styling quite straightforward. Developers typically use StyleSheet Create to define style objects, which are quite similar to CSS styles. For example, you might see something like this. Const styles equals StyleSheet Create. Container. Flex, 1. Padding, 20. Background color, F0, F0, F0. Title. Font size, 24. Color, 333. This style sheet acts as an abstraction of CSS, making styles more manageable and organized. An important thing to note is that, by default, React Native's Flexbox layout is column-based, unlike the web's default row layout. This means components stack vertically unless we specify otherwise. We control the layout using props like flex direction, justify content, and align items. These props help us align and distribute space among items, ensuring our UI looks good across different screen sizes and devices. Altogether, understanding these styling and layout tools is key to building consistent, adaptable interfaces in React Native. Let's take a closer look at scroll view versus flat list and how to choose the right component for your needs. First, with scroll view, it renders all its children at once, which is fine for small sets of content where performance isn't an issue. But the key point to remember is that if you're dealing with large or dynamic lists, scroll view can become inefficient because it loads everything up front, which can slow down your app. Now, on the other hand, flat list and section list are designed for handling large lists. They are virtualized, meaning they only render the items that are currently visible on the screen. As you scroll, they recycle views, which keeps things smooth and responsive. This virtualization is a game changer for performance, especially with long lists, because it prevents dropped frames and lag. Additionally, to make Flatlist even more efficient, you can implement getItem layout. This helps by skipping unnecessary item measurements, leading to even smoother scrolling experiences. So, in summary, for small content, scroll view works fine, but for larger or more dynamic lists, flat list or section list are the better choice due to their virtualization capabilities. Connecting this to our overall theme, choosing the right list component directly impacts app performance and user experience, which is always our goal. Handling text input in React Native is a fundamental part of building interactive apps. The core component we use is text input, which allows users to enter text. One key point is that text input can be controlled in two main ways, either through the component's state or by using refs. In this example, we're using state management with the useState hook. You see, we initialize a state variable called name and then connect it to the text input's value prop. This means that whatever is in the state will appear in the input field. When the user types, the onChangeText prop updates the state with the new input, keeping everything synchronized. Another important aspect is that text input comes with various props to customize its behavior, like keyboard type, which can be set to numeric, email, or other types depending on what kind of input you need. It's also styled just like other React Native components, so you can make it fit seamlessly into your app's design. Overall, understanding how to handle text input effectively is vital for creating user-friendly interfaces, and controlling it through state makes your app more predictable and easier to manage as it grows. Now, let's talk about handling user interactions, specifically touch events, in React Native. The framework offers a variety of components to manage how users interact with your app, from simple buttons to more advanced touchable elements. One of the most basic options is the button component, which provides a straightforward way to add a clickable button. But if you want more control over the visual feedback, components like touchable opacity are very useful because they give a subtle visual cue by reducing opacity when pressed, making the interaction feel more responsive. Similarly, touchable highlight highlights the background when pressed, providing a different kind of visual feedback that can be quite effective depending on your design. Then there's the newer, more flexible API called Pressable, which allows you to handle various press interactions with more customization. It's versatile and adaptable for complex gestures or different types of presses. To respond to taps, you simply attach an on-press handler to these components. For example, using touchable opacity, you might write on press equals alert pressed, and that will trigger an alert whenever the user taps the button. All these components are designed to handle touch events natively, meaning they integrate seamlessly with the platform's touch system, and they also provide visual feedback to enhance the user experience. And for more complex gestures beyond simple taps, libraries like Gesture Handler come into play, giving you tools to recognize swipes, pinches, and more intricate gestures, making your app more interactive and engaging. So, in essence, React Native makes it straightforward to handle user touches effectively, which is crucial for creating intuitive and responsive mobile interfaces. Thank you for reading. I really appreciate you taking the time to go through this material. I hope you found it insightful and useful for your understanding. Remember, the key points we've discussed are all about applying these concepts effectively in your work or projects. It's been a pleasure sharing this information with you, and I encourage you to revisit these ideas as you move forward. Thanks again for your attention and engagement.